Welcome, everybody. Thank you very much for coming. Appreciate you being here this fine Thursday afternoon. We are going to be talking about a topic that is near and dear to my heart, and I think some other people on this call, especially the panel here, is ISA 95, the standard for enterprise to control systems integration. We will be joined by, or are joined by, David Schultz and John Ivey in this call. David Schultz has, what's your count? You keep saying like 25 years of manufacturing,
Yeah,
30
that's close
years?
close to 30. I hate to date myself, but there it is. Yeah, late 90s. I knew where the
So
payphones were, and I had a calling card. One eight
nice.
hundred. What is like call ATT? I think is what it was. So
Yeah. And John, I think you could probably say the same in the number of years. Is that fair to say?
Yeah, about 35 years in manufacturing. So
Ooh, you got a few on David. And John, so
yeah.
your background is more industrial engineering. You have been working in, we'll find out what it is today, but um, the MES space, the level 3 space, at least for a fair bit of your career, I think. Is that right?
yes, yes, absolutely.
So,
Yeah. Yeah.
and Dave, I think you've expanded. You've been across more of the levels than that. Is that fair to say?
Yeah, I started off at what'll be known as the device layer, what is known as the device layer. So a lot of instrumentation, control valves, pumps, really. So it's the things that actually control the process is what I was
Right.
involved in, and then got involved, and then slowly moved up the automation stack, got into SCADA, HMI, and then most of the time now, of course, is spent at what's known as level 3, which is the manufacturing operations management, all that fun stuff. And I try to avoid having to say ERP as much as I can.
All right. So with that said, we're going to get into what we're going to talk about here. We will be talking about this standard and how it applies to the communication of the business with manufacturing and how they interact. There are a lot of what I think of as mental models or a framework to use to look at the business and manufacturing in a bunch of different ways, and then you take those models, apply them, and then start to create a good structure an interface to create a common way to exchange data in a scalable, flexible method. David, is that a good way to summarize it in a few words?
Yeah, I mean, we're just going to walk through what's in ISA 95. How did we get here? What's its purpose? What's its role? What are we trying to do with it? And I think most importantly, how is it valuable as more and more companies do digital transformation? How can this standard assist with what it is that they're doing and exchanging that information?
Awesome. So we'll go through a bit of the background, start with why, as Simon Sinek would say. We'll get into the functional hierarchy, what I think of as the levels, the functional model, which are what Dave told me once is the bubbles, and so I like that word. The manufacturing, I mean, it's a good word. The manufacturing operations model, which you could say is something to the effect of like the scope, if you will. Then we'll get into the information exchange, then activities, the equipment, and then the information models, and we'll be following the process segment as it goes through the define, plan, result process, and then we'll open it for Q&A. In the meantime, feel free to scream, yell, raise your hand digitally to interrupt with any questions. So, David, when you want to share, you just start taking over the share, but let's begin with why. Why do we
Sure.
do this?
Yeah, no, I think it's real important to understand, how did we get here? And it's really, the purpose of the standard is to connect our business systems. So that's that level 4, it's our ERP, all the systems that sit at the enterprise, and exchange information or be able to connect it with our manufacturing systems. And if you go back, once computers hit the plant floor, it became more and more challenging to do that. A lot of people were developing these bespoke solutions that, whatever my flavor of ERP, or, whatever my, and I don't want to just call it an accounting system, but, let's just keep track of inventory. it was something that was very bespoke. Then we had our manufacturing systems that were also bespoke. And so naturally we'd come up with these custom ways to integrate that information. And so the idea was, how do we abstract that? We say in software development, you can always, if you have complexity, you can always add in a layer of abstraction. Well, that's really what the standard was designed to do. And how do we do this in a way that we have these common data models, information models that we can exchange between our level 4 and our level 3 systems. And if you're not familiar with what the level 4 and level 3 is, we'll certainly get into that a little bit. But before I get rolling too much here, does anybody have any specific questions or things that they really want to know about ISA 95 that I want to make sure that I call out once we get to perhaps a relevant section, or maybe we can even just talk about it right now. So I'm just curious if there's anybody that has that.
A couple little topics that me talking with John prior to this might want to highlight a little bit as far as the why. Beyond
Okay.
that, anybody else on this call, anything you guys want to cover? Going once, going twice? Okay. So what John mentioned to me, and I've read this before too, is that the standard, the 95 standard, can be used to establish a common vocabulary and almost like a requirements checklist if you're going to be doing an integration. Certainly it goes a lot deeper than that, but that's almost kind of where it starts. If you've got these abstractions or these mental models, I like to use the word mental models versus abstractions, when you're then looking at the system in a bunch of different ways, those views of things, each of those little bubbles, each of those little levels, each of those little models for information exchange can be a checklist of, have we thought about this? Have we thought about that? Is that fair?
No, absolutely it is. And when you think about any framework, or whether it's, an ISA 95 standard, or maybe there's some sort of sales approach, or design methodology, there's always going to be these common terms that we as an organization want to start using. And once there's an understanding of what the ISA 95 information models are, what they mean, how they relate to the other information models, you start speaking in that language. When I say things like job order, everybody else knows what I mean, and what a job order is, and what are the things that are part of it, and how it relates to all the other things that are there. So really, it's just understanding what's there. So yeah, absolutely. It's having a common language that we can easily understand. We don't have to explain ourselves or anything like that. So absolutely, the ISA 95 standard is another way that we can represent. I mean, really, our position is that ISA 95 is a way to describe your manufacturing operation, all the from start to finish, if you will. So
Yeah,
John, does that treat what you and I were talking about before?
yeah. I think because I think one of the things that was key is that if you've been around long enough and you get involved with these projects, and let's say you get involved with one that's either struggling or has failed, it's almost never the fault of the technology involved or the software involved. It's almost always a misunderstanding, either in terms of expectations, or a misunderstanding in terms of what data is required. So it's if it's requirements or expectations, and then likewise, if you've ever been on a project where, hey, you're struggling with budget, or it's taking longer than you thought, or it's harder than you thought. A lot of times it's because there were deficiencies in the understanding of, oh, this is the data I thought was going to be available, or hey, there's this data that we hadn't thought of. So again, having a common framework kind of helps manage the people and the expectations and of it, which I think is crucial.
Awesome. Good points, John. Good points. And you've never been on one of those other projects you referred to that
No, but
failed
they've
for
all
one.
been raging successes, right?
I'm
Yeah.
sure. I'm sure. I'm sure.
on time, under budget. That's how my projects roll. Yeah. No, and I think it's a great point, John. And it's largely, I mean, how we approach delivering those projects, a little out of scope of what it is we're trying to do, but absolutely, it's let's model what it is we're trying to do first in using this common language, and that's really how you can leverage a lot of the ISA 95 standard, and understand it's over 8, not soon to be 9 parts, and there's a lot there. And we're really just focused on the first 4 of that standard. That's really where a lot of the meat is. But certainly when you start getting to exchanging information, parts 5 and 6 will be helpful for that.
Okay, David, let's get into it then.
All
Functional
right,
hierarchy,
cool.
or as we call the levels.
Yeah, let me see if I can just share the exact window. All right, perfect. So I
There you
have
go.
to ask, can you see my screen?
Yes, sir. We can.
Yes, that's like every webinar. Can you hear me? Can you see my screen? So what I wanted to start off with is understanding that the ISA 95 standard is meant to is a functional architecture. And what I mean by that, when we talk about the various levels, it's we're trying to capture what's going on. What is the time horizon? So, level 0 is you can, take a look at this diagram from part 1 of the standard. That's the actual process. And we're dealing with things that are, millisecond, microsecond in some levels. But, really level 0, level 1, level 2, that's all of your automation system. So that's your SCADA, that's your HMI, those types of things. But that's really the control aspect of that. So what I want to make sure that I draw out here is that this is all functional of when we talk about what a system is doing, this is how we want to think about the levels within the context of ISA 95. This is not a network architecture, meaning this is how you want to connect your information together. That's really the domain of the Purdue model of, how do we connect our systems together and how do we keep things separate? There's the 4 R's of the reliability and the repairability and the response time. And there's a fourth one I always forget. That's what Purdue is interested in. This is not meant to serve as this is how you connect all of your systems across all your levels. So if you're familiar with like ISA 99, 62443, there's really nothing regarding cybersecurity in here as well. And then of course, most people when they think ISA 95, they think the that pyramid, the automation pyramid, which that's a great way to represent a lot of information. And it certainly applies here, but just understand you're just scratching the surface as far as what's actually happening in the standard. All we're really trying to do is say, if it does this function, we consider that a level 2, a level 4 type system, regardless of even if my maintenance system is part of my ERP, so I say I use SAP and their PM module, even though it's part of ERP, which is generally considered a level 4 system, the function of PM a module is going to be a level 3 activity. That is a part of your manufacturing operations management domain. So, just understanding when we start talking about the functional hierarchy, we're talking about what is it doing, what is the type of data, what is the event horizon, time horizon of how much information changes in that. Is that all making sense?
Makes a ton of sense. One of the things that I really like about this, it was a first time I saw this diagram was the time frames. And
Mhm.
then it really hit home. Like, well, the really fast stuff is at the bottom, and the really slow stuff is at the top.
Yeah.
And then also it's the functions that happen at each of those levels. Makes a ton of sense. And that also
Yeah. I
helped
mean,
me clarify way back when exactly what you were saying. SAP is known as an ERP company. They've got all these tools, but actually PM and QM and some others are at level 3. Makes a ton of
yeah,
sense.
absolutely. Absolutely. I mean, the fastest you're going to see things at level 3 is, generally speaking, if we're getting, say, time series data, 5 minutes is probably is more than adequate because not much
Yep.
is happening within the operations management. Now, at your control level, certainly it's going to be a lot faster.
Yep.
So,
Okay, so at this point, the next one, just to keep reference, is the bubbles, the function
it's the
or functional
bubbles.
model, the bubbles. So
That's the
levels,
functional
then
model.
bubbles. Yep.
Yeah, so continuing on with part 1 of the standard, what we're showing with this particular figure is all of the different things or systems that you might find in a manufacturing environment. So you can see starting with number 1 there at the top, you have order processing. And then we go to production scheduling and process and production control. And you can see all of the various systems that you're going to find in a manufacturing plant, where they are somewhat located, and generally the systems that they are going to be talking to and referencing back and forth. So what we're trying to do and just capture here is, so now that we understand what the functional levels are, what are the actual systems? Let's tease out that level 3, level 4 a little bit more, even level 2 of what's happening there and how that data goes back and forth or exchanges through. So I've often found that this diagram is like, oh my gosh, there's a lot of noise here. It's not the easiest to understand, but if you just if you just think about it in terms of there's a bubble, there's a system that's doing order processing, and here's how it's exchanging information with some of the other systems. that's in there. And you'll notice that there's not a line between number 1 and number 3 type of thing. So just think about, that this is what's happening in a plant and all the information that gets exchanged, as well as all the systems that are there.
So for a point of clarity, going from one model to the other, from the functional hierarchy, the levels that a lot of people know and reference, where do those levels exist in this diagram? Because this is now starting to get more into the manufacturing, into the level 3, I think. But is there any level 4 here at all?
Yeah, so I mean, you're going to have order processing. That's generally going to be your ERP. So it's you received a purchase order from a customer, and it's now time you need to make left-handed blue widgets, and you need to make 10,000 of them, type of thing. And then you're going to flow to probably production scheduling. You're going to dispatch that information. There's material control. You'll find that. You have material and energy control. That's probably going to be some level 4 activity, but you also have product inventory control. So that might also be level 4, level 3. So there's a smattering in here, but these are really just trying to get you an idea of the functions that are there. Procurement, clearly going to be a level 4 type thing. Maintenance management, there's going to be a little bit of both in there. And you'll notice that there's this dashed line that rolls around
Yes.
everything, and it'll become a little bit
Yes.
clearer actually in the next image that I show, or figure, to tell you this is really what ISA is focused on.
So is it fair to say that anything on the outside, or sort of on the outside of that dotted gray line, then is level 4, and on the inside is mostly
Yeah,
level?
I would say that's a pretty good rule of thumb.
Yeah. So functions are the bubbles, the arrows between are the data communicated, and the dotted gray line is distinguishing functions between level 3 and level 4. Awesome.
Mhm. Yeah,
Awesome.
I think that's a good way to approach it, and that becomes clear of what it is we're trying to do. So what this is that it's that manufacturing operations management. So this is really, now we're taking everything that occurs within a manufacturing environment, and we're saying this is what is within the domain of the MOM level 3. And that's where you get into this yellow bubble that's everything. And then what you'll start to notice here is there are production, operations management, inventory, maintenance, and quality. Well, those are the 4 domains that we're interested in within the exchange of information within ISA 95. So a little bit later on in this presentation, when we start talking about here's how we exchange information, and here's how we think about how we define things, how we create demand for things, how we present results on those, the production, maintenance, inventory, and quality, those are the 4 domains that we're really most interested in. But what this is doing is now taking that previous image that we have, or figure, and then now saying, okay, this is really, let's drill in or zero in on really what ISA 95 is trying to capture within that, with all the exchange of that information and what
Okay.
its domain is.
So kind of a quick checkpoint. Levels 0 through 4, bubbles, this diagram, but prior with more detail without the coloring on it. This one is, I think of it, the bubbles with coloring in them, and they are defining the 4 domains, which is production, inventory, quality, and maintenance. That's
Yeah, so
kind of
on
drilling
this
down.
one, we saw what information is being exchanged. Here we're saying that information exchange falls under, say, production operations or inventory operations. That's what we're trying to capture. And it's all within this yellow area of, these are the things that are going to be that level 3 exchange of information.
Okay, I'm going to
Good
do
way to think about it.
Okay, I'm going to do it. Well, before I cut over to my share, just to check where we're at in the list. John, any comments or thoughts so far? Or even practical experience around projects? And boy, this would have been helpful way back when.
Yeah, no, I think the thing is, again, having the awareness ahead of time. One of the things when I was involved very heavily with, production scheduling, was the whole notion that, you'd go into customers without an awareness, and they would tell you all their detailed rules around how they would schedule things. But, you had to tell them, look, the only way the schedule is going to be good and valid is if you've got good information being exchanged from all the other systems. And, a lot of that is just working hard to build that understanding that says, we need to, strengthen all the links among these bubbles.
Yeah, Yeah, I think of it as a good way to organize the requirements as I'm getting them. And then, of course, to go through the rest of the process, we'll go through to understand the rest of the relationship between business and manufacturing to then create the interfaces. I love to organize ideas, and these frameworks or these models really help with that. So we've gone from the functional hierarchy, the levels, to
You just muted yourself, Kevin.
so we're going from the functional hierarchy to the functional model, which is the bubbles, to
Mhm.
the manufacturing operations management model, which is the colors in the bubbles. And now we're going to be going into the manufacturing operations information. What data is exchanged? Right? Is that next?
Yeah, that is
Okay,
next. So I need to get back to sharing my
that's
screen
it.
here because it managed to get
That's it.
captured. All right, so moving right along, now that we understand what information is exchanged, we're looking at what's the domain and then what are or what's relevant to ISA 95 and what the domain is we're interested in. Let's bring it full circle as far as how we're going about to now defining, not only do we know what those domains are, but what's the type of information that we want to exchange and move around. So again, a little bit later, we're going to do the evolution of what's known as the process segment. So the first thing we want to do is what's all of our definition. We're trying to define what are the things that we're doing, whether that's on production, maintenance, quality, or inventory. And that can be something like, okay, we're going to make left-handed blue widgets. And here's how we define the overall manufacturing of that information. So that's where we're going to focus on that bottom left of the definition information. And there are models that are associated around that. When I get into the activity models of part three, the next thing we'll do is the capability of here's how I define how I want to make it. Now looking at out across my manufacturing environment, what are the capabilities that I have? So what can my equipment produce? What are the people that I have? What are they able to produce? What inventory do I have in order to do that? Or if I need to, make something or to repair something rather, it's what am I capable of? What are the technicians and maintenance people? What are they capable of doing? So first, we're going to define what it is we're going to do. We're going to say, okay, what is the capability of everything that I now need to do? And then finally, I'm now going to get into that schedule and request information. So the schedule is now where I take a definition, I understand the limitations of what I can do. Now I'm going to schedule those 10,000 left-handed blue widgets. I might have to divide that up over, say, 5 different production areas, or what's known as a work center, or there's some granularity that I have to place on that due to those constraints or the capability information. And then finally, once I get into the actual execution of that, I've scheduled, I wanted to start at 8 a.m. on Tuesday. The last piece of information I'm going to get is that performance or my response information. How did I actually do with did I start on time? Did I make the right number of material? Did I get it done in the period of time that I had scheduled that information? Did I only consume in the material that I wanted to consume? Did I use the energy that I intended to use? Was it, all the people that are associated with it? That's really what I'm trying to get at. So defining it, what is it, capability? What am I capable of doing, or what's the ability? Let's get it actually scheduled and start making the request of IA. Here's how I want to start using some of the resources that I have within the manufacturing. And then finally, the performance of how did I actually do? Let's, that difference between the schedule or the plan as well as the performance, the response. What did I, the plan versus actual is what I'm trying to get at. And that's where you really get into a lot of your KPIs in manufacturing is here's what I meant to do, here's what I actually did, and let's take a look at what those differences are. So starting if here's the information of the systems, here's the information that's exchanged, here's the domain, and now within that, what are the models that are associated with each one of those domains within the manufacturing, and what information starts getting shared.
So I think of this as those four domains again: production, maintenance, quality, inventory. Then let's say the types of things that need to be exchanged, and they're fairly obvious here: top left, top right, bottom left, bottom right. Schedule and request, performance, response, definition, and capability. So this is almost a reminder that hey, we need to define, that create definition information. We need to create information around what capabilities we have. Scheduling and performance are pretty obvious, but those are less obvious. So is that a kind of a fair way to look at this?
Yeah,
This
no,
really
absolutely. I mean,
keeps you on top of
say
things and make sure you define the right stuff.
yeah, so say I want to make those left-handed blue widgets. I need a blue handle and I need a blade. So that's how we make the blue widget that I'm going to take a look at. If I need to make 10,000 of them, what's my inventory capability? Meaning, do I have 10,000 of those pieces? And if I find out, yep, I do, now I actually schedule it. So I'm going to want to release information from my warehouse. I need 10,000 blue handles and 10,000 blades. I make that request, and then finally I'm going to have the response of how many did I actually consume? Because, well, David was working on the line that day, so we ended up creating some scrap. So, sometimes
Well,
that can
that
happen.
David,
Yeah,
that
yeah.
David.
I
Michael,
know we haven't had a
you have a
lost
question?
time accident since David left, right? All right, Michael, you had a question.
Yeah. No, this slide really hits home for me. Kind of this information. One of the challenges I think we have using ISA 95, and I'm curious to get your perspective here, is that a lot of this, like the definition information, the capability information, exists in systems today. Maybe it exists in multiple systems, and that's part of the problem is reconciling it. But does
Mhm.
ISA 95 give kind of a prescriptive point of view on how you define and describe that, irregardless of the system that the data is stored in? Or is it kind of that, is this more kind of informational to say, hey, we have these kinds of activities, this kind of information is exchanged. You kind of have to figure out how you manage your scheduling, your production scheduling and planning systems, or your PLM system that may describe some of your product definition and so forth. I mean, how best to bring ISO 95 standards to kind of making sense and kind of standardizing that language of all the different systems that kind of contain this information?
Yeah, admittedly, we're getting into this exchange capability is probably the one that's used the least, and that's mostly because there's so much domain knowledge around what we can actually schedule on what line and how things need to be done. Like, say I'm a cheese manufacturer, or I'm an ink manufacturer, and there's a certain order that I have to make product. I kind of know that inherently. So in terms of that, capability information, generally that's not something we get involved in as much. But there is an abstracted way to have a mechanism for when we exchange that information that we are going to do it in a common way. Probably didn't answer your question as maybe as best as it could have been, but it's certainly there. Admittedly, there's not a lot of practical application, or there's not as much application of the capability model as the other three.
Okay,
Before
thank
we
you.
go over to Jeff, Mike, did that help?
Yeah, no, it certainly did.
Okay, Jeff, sir.
Yeah, just a clarification question for my understanding. So if I heard what you said correctly, or correct me if I heard wrong here, but all of these, all of these labels that we have essentially out at the end of the lines, do those represent standard data models that
Mhm.
are in the, so that's in the standard, and there's, standard models built to represent each of these entities, correct?
Yes, so there are capability
Okay,
models, there are response requests, and there's definition models. Yes.
okay,
Yeah. Now they're
great, thank you.
generally more toward the resource, and I'll explain what a resource is here shortly. But yeah, that information is there.
David,
Okay, great,
in
thank you.
your plan for the discussion today, will you be kind of tying those concepts together to help make the connection for Jeff?
But we'll get there. Because I think the next picture we're going to do is we're going to look at an actual activity model.
Oh,
And I think this is where it'll start making sense.
good. So we've done levels, bubbles, colors in the bubbles, information exchange, just covered that. Now we're into the activities.
So what we're looking at here is from part 3 of the standard, and what part 3 is focused on are the actual activities. We're actually doing something. And of course, we like having different colors to represent a different phase, if you will, of the actual manufacturing operation. So if we're going to start again at that bottom left with the definition management, and definition management is just, again, we're defining what it is that we are trying to do, whether I'm going to make my left-handed blue widgets, I'm going to repair a pump, I'm going to move some inventory, or I'm going to do some kind of quality test. on it. That's the definition. That's sort of the how you go about doing this thing. A good way to think about this is that when you start talking about, like, say, work instructions for an operator of, here are the steps, or let's say I'm putting together, the Lego Millennium Falcon. The definition management is going to give you those, here are the things that you're doing in each one of those steps. So that definition management is oftentimes going to be known as an operations definition. So an operations definition is all of the steps that it takes to actually complete whatever it is that we're trying to make. The next piece of or something we're going to define is the resource management. And resource management is, so there are 4 resources that we'll talk about. It's personnel, it's material, it's equipment, and it's a physical asset. So within that, it's of those resources, of those 4 resources, what am I capable of doing? What can my assets do, my equipment do, my personnel do? What can my material do? And that's part of that resource management area. So we're just defining things. So now we want to get into the detailed scheduling. And the detailed scheduling is now where we've defined that we're going to do one of those activities in those 4 domains. Now we actually want to put it on a calendar and make these operations requests of, I need to go out and I need to make this particular product using this material, this physical asset, this personnel or this person, and this equipment. I don't remember which one I missed there, but I'm going to use all those and I'm going to make all of the requests for, on this particular day, this is what we're going to do, and here are all the things that I need associated with that. And then finally, I'm going to do that finite scheduling. That's, I like talking about in Star Trek when Jean-Luc Picard says, set a course for the, the Omega system, and somebody gets that all ready to go. And then he says engage. It means we're finally ready to go and we're going to pull the trigger. So that's what dispatching is taking that scheduling and actually move it into, now we're going to take this into production type of thing. So generally speaking, when something is dispatched, we can no longer make a change. We're actually going out and getting ready to do it. We're pulling inventory assets. We're tying up equipment and personnel for that. So I'll take a quick pause. Now we've defined it. We've scheduled it. We'll move into the actual execution and result, but real fast. Any questions so far?
It's good.
Oh, there's a question.
Just a quick question. So the definition management, I'm assuming that includes like processing parameters, recipes, that kind of information, right?
Yep. Yeah, that's going to be part of your, there's material requirements that are going to be part of a recipe, and they could also be, say, set points on a piece of equipment. So yeah, that's all going to be part of that definition of how things happen.
Okay.
Yeah, I get asked sometimes, where's the BOM fit? Well, it depends on where you're using it. That's it can be any one of those. So, and that's the beauty of the standard, is that it's the same type of thing exists. It just depends on where you're using it. Will determine where that is. So once we defined how to make it, we've scheduled it. Now we're actually, in the process of, I'm now traveling at warp speed toward the Omega system. I'm now in execution management. I'm actually doing the activity, and then I'm also responsible for data collection of what's happening there. So it's in my plan is the detailed scheduling dispatching. Now I'm going to get into some of the actuals, and I start collecting data as part of that execution. So, we've defined it, we've scheduled it. We're now in the process of doing the thing that we were planning on doing, and we're collecting data as a result of that. So that's the action step, where we're actually, if you were to walk out to the line and see something going on, that's exactly where you are. And then at the very end, of course, now we're going to get into how did we actually do, and that's where we're finally going to have the operations response, or gain its performance there. Of we're going to track materials as they move through. We're going to track assets. We're going to track personnel. These are all just trying to get at the results phase of what actually happened within that manufacturing environment. It's sort of the how did we do against what we intended to do, and that's really where you're going to get into the response objects and that tracking and performance analysis. So again, performance analysis is those KPIs of the blue area versus the green area, what actually happened. So this is an activity model. You'll see this in part 3 of the standard. Then it's more enumerated for each of those 4 domains. So whether it's production or maintenance or quality or inventory, you'll see this exact same type of relationship for all of those. And then of course, when you get into part 4 of the standard, there's a little more information that's actually some of those information models that we were talking about earlier that are actually enumerated here. But I didn't want to get that far into the weeds for this presentation.
Jeff, did that
Any
help?
questions?
Anybody else? John Ivey, feel free to chime in if you've got any thoughts so far.
You know, the other thing that I would mention on this, again, all of this is, most of the stuff that I've talked about has come from a a project perspective. But the other thing that this is helpful for is, for people that are crafting these solutions, that realize, again, most of my career have been affiliated with a specific company, a specific vendor, but that didn't mean we got to deal specifically with our own stuff. So the better handle you have on this, it helps you, design solutions that are, very, very easy to become interoperable and play nicely with, other sources of data or other, software that might be providing pieces of this. So it's a helpful framework for that as well. So
yeah, fun little fact: if you really do a good job of defining your activity model for whatever it is you're trying to do on a project, you're generally going to get a pretty good functional specification, user specification for what it is you're trying to do. So let's define it. What are the resources, et cetera, et cetera. So very, very helpful from just thinking about how we actually do something in there.
All right. So let's move into what likely everybody has heard about.
Yes. So this is where we're going to get into the equipment hierarchy. So there's a equipment hierarchy model, and this is what people is generally know as the enterprise site area line cell. You can all say it with me. We can probably say it in our sleep. Understand that what I'm showing you here, there's a further intent than what we're going to be covering in this particular webinar. But I think it's important to understand what are some of the equipment and how do we want to start thinking about doing the equipment model itself. So earlier when we were talking about in this discussion of, if you define things really well up front, it makes it a lot easier to do at execution time. So all I'm showing here is that you're going to have your equipment model, and we're also going to have something that is called the process model. And what your equipment model does is, this is where we're defining what are all of the logical groupings of areas. So from the, all starting at the enterprise down to work center and work unit, what are all the equipments? It's the work center. This is in the work units of where we're going to do something. And then of course, there's the process segment itself that we're going to spend quite a bit of time on, but that's the actual, how do we actually make something? So equipment is where we're doing it. It's more of a location versus, what are we doing there? That's going to be the process segment and how we define it. But I wanted to show this just so there's an understanding of, depending on what type of manufacturing environment you're in, and if you're in a batch process, you're going to call your work center and work unit a process cell unit. Unlike say a discrete, or as opposed to a discrete process, which is where you're going to have the line in the cell, or production line work cell. Technically, something that'll get overlooked a little bit is there's actually storage zones and storage units that are going to be the equivalent of those equipment work centers and equipment work units. And we treat them much the same. When material moves from one to the next, we need to have a process segment that's associated with that. And then, of course, there's going to be some S88 aficionados. So we also want to bring in the equipment module and the control module to understand, how does this equipment hierarchy fit with the S88 standard that involves it a little bit more. S88 is really around batch control. There's a little bit more to it, but generally speaking, that's how people understand it. But we will use this legend, or this equipment hierarchy, in what's known as hierarchy scope. There's a whole lot of, we could do an entire webinar on just hierarchy scope itself. But when we start exchanging information, generally speaking, we're going to use that hierarchy scope as far as, where are we sharing this? In my work unit, where I'm now sending down that recipe, am I just scheduling on a work center? and that's what we want to use in terms of that topic hierarchy for the exchange of information. So this is really where we want to start, is just understanding what is the equipment.
So, and it's nice. It's helpful here in that, there's some commonality, and S95 was certainly well informed by S88, so they're certainly compatible, which is good, because a lot of times you'll get, even within the same facility,
Yep. Good
you'll
point.
get different processes, right? So very common in pharma that, hey, it's batch processing to create the bulk product, but then it's all S95 and discrete to bottle the and package and get it out the door. So
Yeah, good
Yeah,
points.
absolutely. And and there's also a technical report that talks about how you use S95 and S88 together and what that exchange looks like. Again, S88 is more around batch control and how you do the actual batching system, if you will, and then how that information from that batching system will then get exchanged. So that's really more of that level 2 and how it gets exchanged with level 3, level 4 for the rest of the enterprise. So a lot of really great content out there.
Some good stuff. So we're, again, kind of a review. I like to do this to get everybody mentally checked in with everything. I'm just going to do a quick share before you move on, because this next topic, I think, gets deep. So here we're looking at the functional hierarchy, which is the levels, and then we went to, I think we're starting from the very broad to the very specific around functions that we're thinking about, creating mental models or abstractions for manufacturing in the business. So we're getting into what I think of as the bubbles diagram with the time horizons, et cetera, and the functions at those different levels. And then within that, the manufacturing operations model, which is the colors in the bubbles, and then the information exchange, then down to the activity. So we're kind of getting, as I see it, though, correct me if I'm wrong, we're getting deeper and deeper, deeper and more specific, and covering a lot of different ground. And then we've talked mostly about functions. We've talked about scheduling, performance, capabilities, and definition. Then we're getting in and covered activities. Now we're getting into equipment. So it's almost like we're getting all the different views of this whole relationship, and then we get into the actual information models that we exchange now that we have a good picture of what's going on. Is that a fair way to
Yep.
take the big
Yeah,
picture?
we're just zooming right on in. So if you've ever seen, there's a Cosmos video, we zoom all the way out to the known universe, all the way down to something at the microscopic level of atoms. Well, we're sort of getting in there, maybe not all the way down microscopic, because there's a lot more here. But I think there'll be a really good understanding of the information models and how they all fit together and how it can be used.
Makes sense. Okay. All right.
Cool. So I talked earlier about there being the 4 resources. So the way that ISA 95 was put together, you think of like Lego blocks or building blocks for whatever it is that we're wanting to use, and the very starting point of that is going to be our resource models or resource specifications, and those 4 resources are material, equipment, personnel, and a physical asset. I just have the asset or physical asset represented as just an A here, just for some commonality of how many letters are there. But just technically speaking, it is a physical asset is technically what that resource is considered within the ISA 95. So I think material is fairly straightforward in terms of it's either a product, it's a raw product that I'm consuming, or it's a finished good that I'm producing. Those are generally how you're going to be using those 2 materials. Your personnel, that's going to be an operator, a technician, a quality person. It could be just somebody who's moving that inventory, but a person represents an actual physical, well, as the name would suggest, it's an actual person that works in your factory that we need to account for in the model. I don't use that one as often. I mean, usually it's the material and the equipment that are there. The difference between equipment and physical assets. So equipment is geared around role-based equipment, and that's generally the work center of where we're going to be doing the majority of that's really where the work happens within the ISA 95. Is we're at a work center, this is what's happening, but it's role-based. versus a physical asset. So a good way to think about the difference between the two is a physical asset is something that you can move. So say, for instance, I have a pumping station. I'm part of a metropolitan sewer district. The equipment is going to be the pumping station, but the physical asset might be the pump that sits there. But I can replace that pump out every 500 hours. And of course, that would be a maintenance activity associated with it. But the role of the pumping station is always there. And then there's a pump that's associated with it. Or let's say I'm in a chemical manufacturing process. I have some reactor, but in that reactor, I might have different pieces and parts that I'm going to put on, say, an impeller that are associated with that. That's going to be the physical asset. So those are the four resources that exist within the standard, and you will see those utilized throughout the rest of what it is we're trying to do here. Yes, Kevin.
Where would you put robots for moving the raw materials or finished goods, AMRs, etc.?
So, I mean, generally speaking, we don't treat those as a thing because all we're really trying to do is they're moving inventory from one to the next. So I'm probably going to be a physical asset if I were just to spitball something right here. But usually I'm using robots for moving, say, some materials.
So for material movement then.
Yeah. It's no different than having a person, move that material.
Fair.
Yeah, I guess the only thing in that case would be, if it falls under the maintenance piece, maintaining the vehicles in the fleet. But I don't think that, the status, of those really would affect the, the operations management. It's more the maintenance piece.
Yeah.
For things
So
like that.
yeah, but within the ISA 95 and the exchange of information, if I needed to repair the robot, then there's an asset that I need to fix. So that's the assets. I need a person to do it, and then what are the materials that are required to make that repair? So it's the spare parts kit that's always there. So coming back to the familiar, we're going to start with the definition. So if you remember, going back a little bit, we always said, the first thing we want to do is define things, and that's where we're going to get into the process segment. And so the process segment, you can think of it as the smallest unit of work within a manufacturing process. Definitionally, within the standard, it's really the business process, or it's defining the business process of a common understanding of how we do something. So if I need to make left-handed blue widgets, this is going to be that process segment. It's just going to be the definition of how we go about doing that in a way that our level 4 system understands what's happening, or the actual process of making it, and what are the materials, what are the people, what's the equipment, and what are the assets that are associated with that. So you'll notice here at the top, this is definition. We're just defining the what. And then you'll notice that there is a level 4. So this is who is going to own the data. The level 4 system is going to understand and manage what is known as the process segment. So within that process segment, we're going to use those resources. And there's also a process segment parameter. What the parameter is something that it's a property of whatever it is that we're trying to make. That's not a material, physical asset, person, or a piece of equipment. This could be maybe your a performance rate. If you're trying to do some OEE on a particular production line, that might be one of your process segment parameters. Just something about the process that I need to define it here, but it's not a resource, is what's meant to be as a process segment. But this is going to be the process segment. So we're taking those resources, those building blocks of our resources, and now we're going to start putting it into how do we actually do something here. So process segment, really, if you think of it, smallest unit of work, it's a template of whatever it is that we're trying to make. We're going to make a widget.
Before you go on, can you zoom out a little bit just so we can see what each of these columns are? We can see the levels at the bottom. Yeah, there you go.
Okay.
So you have definition. Yeah.
Yeah, I need to redo this one because it doesn't show as well as I would like for it to, because if I zoom out too much, then you can't read what it is. So it's just, it's one of those, it worked well when I created it. And then once it gets on a screen, sometimes it's like, well, no, I can't actually see what we're doing.
And we can zoom in if we need to, but this view is perfect because we can see the definition, demand, et cetera, process with the levels at the bottom. Awesome.
So now we're going to take that process segment and we're going to evolve it. So you're familiar with Pokemon. We're going to start doing the evolved form of the Pokemon. So now not only am I going to define the unit of work, or the smallest unit of work, or a common understanding, I'm going to start piecing these process segments together in what's known as an operations definition. So a process segment's more of a template. An operations definition is going to be what are all of the process segments that are associated with whatever it is that I'm trying to make. So what you'll actually see in practice on an operations definition is it could be a number of process segments, all having their resource specifications and what are those parameters that are associated with whatever it is we're trying to do. So process segment, make a widget. Operations definition, make a left-handed blue widget. On line 1, utilizing these resources. So we're going from general to specificity within the operations definition. So we're going to actually call out, instead of having, say, material classes, we're going to have a material definition that's used there in the operations definition. So that's all, still going to be level 4 the operations. So now we're going to place demand on it. So now we know what is the smallest unit of work. We've evolved that into the operations definition. What are all the things that we need to characterize? Again, level 4 view. Now we're going to place demand, and this is the operations schedule model. So when your ERP has a production order that it's sent down to your manufacturing process, we generally consider that an operations schedule. That's what's coming down of, you have until Friday to make these 10,000 left-handed blue widgets. And now we're going to get into the request part of whatever it is that we're trying to make here. So I'm just going to schedule equipment. I'm going to schedule my materials. I'm going to schedule personnel, and I'm going to schedule physical assets. So it's now evolved from just a basic definition to where I'm going to place demand, and we're going to start measuring against that. So this is the demand, or it's the schedule that's there. So all we're doing is evolving whatever it is that we're trying to do. And at this point now, that process segment is going to be known as a segment requirement. That's going to be the model. So far, so good. Oh, there's a question.
Yeah. Hey, sorry, Dave. So am I understanding it correct that the operations segment is really a specialization of the process segment?
Yeah, so what we're doing is on process segment was just a generic version of we're going to make something, where this is now a specific one. We're going to make left-handed blue widgets on line 1, and we're going to utilize these material definitions and these physical assets, using the blender type of thing.
All right. And then when you're getting to segment requirement, it is that operation segment within kind of a time frame. Is that
exactly
another way?
It's
okay. Yeah,
exactly. So now we're just putting a calendar event on it. So if you actually looked at the model, really what you see on the operations schedule is basically an operations definition with some dates on it.
Yeah. Okay. No, this is helpful to understand how this kind of applies to like MRP and plant, like how you would actually think of scheduling against your constraints. So that very helpful. Thank you.
Yeah, absolutely. The thing to keep in mind, though, is that your ERP doesn't always have a view into all the little things that have to happen to actually make those left-handed blue widgets. There might be a kitting process if somebody actually needs to go and move that material from my warehouse and move it out to the plant floor. Well, all the demand is seeing is go make 10,000 left-handed blue widgets. Here's all the things that are associated with that. But it's within our level 3 system. So this is our manufacturing operations management of, now not only do I need to make these things, I need to kit these. I need to get the parts ready to go or put them in bins or something along those lines. So what the standard allows us to do, and this is in part 4 of the standard, is that we're now going to get into the work definition. So there's a commonality between operations and work, only from the sense that it's a level 3 view of what it is we're doing. There's a lot more granularity. So you're going to see the same types of the relationships are going to be there. A lot of the boxes are going to be the same. What's there, we just call it something a little bit differently. So we've defined what that work is in kitting. We've defined what the work is in actually making those particular products. We've defined what's actually involved in, say, packaging those particular products. But this is where we're getting into the level 3, is just doing the same types of things, and we're now going to define what it is we're going to do. And of course, naturally, I'm going to schedule that. So I mentioned earlier of I need to make 10,000 left-handed blue widgets. Well, now I'm going to define 2,000 of those at a time. And now we're going to place that demand where I'm going to move it across, different lines, different dates, that as long as I meet the demand of my level 4, I'm okay, but I'm going to break it up so I can keep production going for everything that's there. So go ahead.
I'm just say, if I may here, a lot of times this is also like a common shortfall of the level 4. So for instance, yes, you can say that SAP or not to pick on SAP or Oracle, but any other ERP system might understand the the definition of the work that's required. But level 3 is really where you get into, okay, for these left-handed widgets, yes, I've got 5 machines available, but really only 3 of them are good for processing it. Or the other work requirement might be that, oh, I need to have 2 operators, and if so, that will take me 4 hours. I can do it with 1 operator, but it'll take me 8 hours instead. That kind of
Mhm.
granularity, again, is one of the things that the level 3, the detail that the standard addresses, that needs to be, if you really want to do effective scheduling or analysis of the operations.
Yeah. Yeah, there's a couple of models on here that I'm just going to hand wave and gloss over. And of course, that's the work master and the work directive. So what the work master is doing is it's now taking those activity models from part 3 and it's marrying it up to the part 4 of the standard itself. So work master, think of it as like the Betty Crocker cookbook of this is the master recipe of how we're going to go about making these, say chocolate chip cookies in this case. What a work directive does is actually at the time that we're actually going to start making cookies, we're going to realize, uh-oh, I don't have enough chocolate chips, so I'm going to throw in some butterscotch chips. Gives you a little bit of flexibility there, but then we're going to go forth and prosper on it. So work master is the definition, work directive is just the demand. There's a lot more to it, but just think of those in that way. But I didn't want to just skip over those and ignore them. But what ultimately they'll result in is the idea of the job order. So the job order is the evolution of the process segment within the very granular level 3 system of what actually occurs down on the plant floor. To me, yellow, this is where all the activity, this is all the fun stuff. This is the boots on the ground, concrete side manufacturing process where everything occurs. And this is just, we're now getting ready to dispatch, and this is the demand we've placed on it. So that's the scheduling piece. And then finishing up on what we're doing, now we're going to get into the work performance and the operations performance. So now you'll see, if you guys remember the old Mad magazine where you had that page where you could kind of fold it over on itself and then unfold it. Think of this yellow section is like that. You may not have the work schedule as part of your operation, but what's going to happen is now out of that work performance, so all those job orders we said that we were going to do of, I'm going to make these various batches of these chocolate chip cookies. Now I'm going to see how did we actually do on the manufacture of those, and that's where we're going to get into the work performance of what materials did we actually use, what equipment did we actually use, what people did we actually use, what were the physical assets that were actually used. So demand, that's the plan. The results, that's the how did we do type of thing. And then finally, all of those job responses, we're going to roll those up all the way into our operations performance model, which means now this information is going to get reported back up to our ERP system, and it's going to now know of these 10,000 left-handed blue widgets, here's the materials and all the actuals and that type of thing. Even though they were 2,000 at a time, it's going to just get reported against how are we doing in terms of what the ERP said we're going to do by Friday, and now we know, yep, we actually have those done by Thursday. It's not going to care about the level of granularity of what actually happened and how it was made. So,
Michael,
Okay, yeah, Dave, can apologize. This is really
You're
good
fine.
material.
this is why we're here.
Another concept that I thought I read somewhere in the standard, and I'm kind of wondering if it relates here, is this idea of kind of different variations of recipe, like a general recipe, a master recipe, and a control recipe.
Mhm.
One thing that I've seen and we kind of work with is that you kind of have your plan of what you're going to do, which maybe, when you're scheduling your month out, okay, that's maybe you're using more of a general recipe to understand your constraints. As you get closer to the work, maybe you're moving to the master recipe. It seems close to be that work master definition.
Mhm.
And then the control recipe, what you actually do at the time you're doing it. Is that
Mhm.
the work directive? Are those concepts
Yes.
related
Yeah.
in a way? Okay, good.
Yeah, absolutely.
Okay.
So work directive is really when you're getting ready to run the thing. If we're going to do a work directive, this is where you're now going to just load the recipe of what you're actually going to do, realizing it, you know what, So I like in a plastic extrusion, I may want to have, my work master says use a particular resin, but the time you're actually going to make it, you can use an alternate, that is allowed in there. That's going to be the work directive. That's going to be the recipe that you actually load at the time you're getting ready to make a particular product code. So
Okay.
work master is the Betty Crocker cookbook. The work directive is how your grandma actually made them at the time she made them.
Gotcha. Okay, great.
Yeah.
Thank you.
Mhm. So work directive was the George Picard said, or Jean-Luc Picard said, engage.
Yeah.
That's work directive.
Well, and when you get to like measuring how you did, I find that differentiation is helpful, because if you're holding yourself to a metric of kind of what the general plan was, but there were specific constraints at the time you actually did it, you might want to know how you're doing against your higher level abstracted plan versus how you did against that specific implementation of that job. So the work
Absolutely.
direct. So yeah, okay.
Yeah, and that's why you have it. It's just a granular of level 3. Your work models are owned by your level 3 system. So when it's exchanging information between other level 3 systems, you're going to be using the work models. And more often than not, even if the infrastructure doesn't support a work model, we're still going to model everything. It just means our work definition, work schedule, work performance. It's just going to be a one-to-one relationship with your operations.
Yeah,
But there's a lot more flexibility and granularity when you're using job responses, job orders, than just limiting it to the operations models.
Excellent. Thank you.
That's my pleasure. So that's basically what we meant there, what I wanted to cover here. I think we're kind of right at time. We're a little bit past that. So I think we're just going to get into the Q&A section of, if there was some things that were specific here. But really the key takeaway here is that the building blocks of ISA 95 is that we have the resource models, and then we're going to have that process segment that just evolves its way through from an operations segment to the segment requirements to job orders to job responses and then operations responses. I think really is sort of, if you remember nothing else of this particular presentation, that would be the one key piece.
John Ivey, any final thoughts before we get into Q&A?
No, I think we've like I said, this was a great overview here, and no, I don't really have anything to add at this point. Thank you.
Okay, cool. Any questions in the Q&A? It's not officially a Q&A until we say it's a Q&A. There you go. Any questions from anybody? Great questions so far. Really appreciate them. Any others? I have a couple, if nobody else. Well, I'll go. Well, people might be thinking of them. So, David, some of the work that we do, like for some large metals companies where they've got a bunch of plants, bunch of old systems, and they want to start to decouple from those and put other systems in place. How do you actually go through the process of using each of these models, each of these mental models or abstractions, arrive at that information model, and then maybe just touch on the how you define and create the interfaces? How do you think through that? And feel free to continue using the chocolate chip cookies or left-handed blue widgets kind of thought, like practical application, without getting it, of course, too many details.
Yeah. So, I mean, really the approach is it always starts with, what I call the master data model. And even though that has a specific meaning, say within an ERP type environment, the idea here is that we're going to define what is our stuff that's there. So I talked a little bit about defining the equipment model. So we really want to understand, generally we're going to be there's an enterprise and a site that's going to be focused on, but now we want to get into what are the areas. Within that area, what are our work centers? What are our work units? What are our storage zones? And what are our storage units? And then what are all of the flows of their particular process? So we're going to define that equipment. And then the next piece we're going to do is actually define the process itself in terms of when material moves, where does it start? Where does it end up? And what are the associated pieces of that? So what the ISA 95 standard does is it teases out, again, those activity models of what are the things that we need to define. But for us, really everything is comes back to the master data model, modeling of the equipment, modeling of the process itself.
So it's
that's
almost
how we
like
go about doing it.
for some of our other activities that we do, it's almost like taking an inventory, not an actual inventory of raw materials or finished goods per se, but an inventory of what exists, using these models to define what we need to take an inventory of, and then defining the communications.
And then when I want to schedule work on a work center, and within that scheduling of the work that I'm actually moving that material, there are going to be some of these some of these models will reflect whatever it is we're trying to do. So the exchange of that information is now I have an operation schedule or a work schedule. Within that, I'm going to have an operation or a work request. And then I'm going to have a job order. And within that job order, I'm going to have the requirements of material, the resources. So the materials, equipment, personnel, and the physical assets that are there. So that's how we think about the exchange going through. So, going back to some of these legacy systems, you want to take what's there, you want to translate it into an ISA 95 model, and then you're going to undo it for the consuming system itself. But what this gives you the ability to do is, regardless of what those systems are, moving forward, you'll be able to exchange that information because you've already defined what that structure is going to look like.
So in a new system coming in, you've got the structure. You modify it to communicate with that structure, and then at that point, aside from a lot of other work, it's a straightforward swap.
Yeah, pretty much. Yeah. It's simple, but it's not easy.
That's a good phrase for it. All right, that's a good place to end. It's simple, but it's not easy. Good. Awesome. Any other questions from anybody else? Great conversation, great presentation, John and David. Thank you so much for your time. Really appreciate it. Thank you.
It's my pleasure. Thank you, everybody, for attending.